Hello everyone, today we are going to learn Chapter 1 Locating Places on the Earth from your social science textbook. In this video, I'll be covering each and every line from the chapter so you don't miss anything important. Make sure to keep your notebook and pen ready and take notes while watching. This will help you remember the concepts better. You can pause or rewind any time to write things down. So, let's begin. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not a perfect sphere but is slightly flattened at the pole. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try and flatten them on a table. You will see that you cannot do it without tearing them at the edges. Mapping means making a map. Mapping the Earth means making a map of Earth. Mapping the Earth is not easy because our planet is not flat. It is shaped like a sphere, just like a football or a globe. And Earth is not a perfect sphere. It is little flat at the top and bottom called the poles. But to make things simple, we usually say it is a round sphere. It's not possible to show a round shape perfectly on a flat paper. To understand this, take an orange, peel it in 3 or 4 big pieces. Try to press those peels flat on a table. What happens? The peels will either tear, break apart, or they will fold, make wrinkles or bumps. That's exactly what happens when we try to draw the round Earth on a flat paper. It doesn't fit without changing its shape. Now, consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars and constellations in the sky, etc. Now, think about a globe. It is a round model of a planet, just like a ball. A globe has a map drawn on it. This map could show the Earth with countries, oceans, etc., or the Moon, or the planet Mars, or even the stars and constellations in the sky. So, a globe is a special way to show round things like planets and stars in their real shape. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metal, plastic, or cardboard. So, what is a globe made of? It is usually made of materials like metal, plastic, or cardboard. This globe is a physical object, something you can touch, hold, and turn to see different parts of the map. Here, we will study the globe representing the Earth's geography. Because the globe and the Earth have the same spherical shape, a globe will better represent the geography of the Earth than a flat map. So here, we will learn about the globe that shows the Earth's geography. That is, its countries, oceans, mountains, and all places on Earth. Because the globe and the Earth both are round. The globe shows the Earth more accurately than a flat map. That is, a globe is better at showing the real shapes and positions of the countries and places on Earth. Let us now explore some of its features. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops all the same size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So, you would give directions like, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Imagine you're in a big market. The market has rows of shops, like lines of shops going left to right. If you say, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance, it means we need to find the 5th row from the entrance. Let's find the 5th row. The first row is closest to where you enter. So, let's count. 1, 2, 3, 4, 5. In that fifth row, count the shops one by one. 1, 2, 3, 4, 5, 6, 7. So, this is the 7th shop. That's exactly where you want to meet your friend at 6 p.m. So, this way, your friend can find the shop easily without getting lost. Now, consider a chessboard. To record moves by advanced players, letters are placed alongside the main pieces. From A to H, see the image, and numbers from 1 to 8 in between the two sides. This simple system allows players to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from d2 to d4. Now, let's think about a chessboard. Chessboard has 64 squares arranged in 8 rows and 8 columns. Rows go left to right and columns go top to bottom. To help players remember and record their moves, the columns are labeled with letters from A to H and the rows are numbered from 1 to 8. You can see this in the picture. This way, every square on the board has its own name like D2 or D5. Let's say you want to find the location of this square. It's in column C and row 5. So, the location is C5. What about this one? It's in column F and row 3. So, the location of this square is F3. In this picture, we can see that the white player has started the game by moving the queen's pawn 2 squares forward. A pawn is like a foot soldier in an army. Each player gets 8 pawns which are placed in the second row. Row 2 for white, row 7 for black. Queen's pawn refers to the pawn that stands in front of the queen. Pawn is the smallest piece but it goes first in the battle. So, here pawn is moved from square D2 to square D4. Let's explore. Using the same terms, write down your move if you play back and respond with the same move. So now it's your turn to play as black. If you move the queen's pawn, that is the pawn in front of the queen 2 squares forward. 1, 2, what is the location? D5. So what was the original location of the pawn? D7. So the pawn moves from D7 to D5. You can also try to think of your move and write it down using the letters and numbers. The system used in these two examples may be called a system of coordinates. Thanks to their 2 coordinates, the stationary shop as well as the chess square on the chessboard can be precisely determined. What is the system of coordinates? The method we use to locate the stationary shop in the market is similar to how we identified the squares on the chessboard. Both use a system of coordinates because both places have 2 coordinates like the row and the shop number or the letter and number on the chessboard. You can find the exact spot easily. So thanks to these 2 coordinates, you can always say exactly where something is. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. Just like we use 2 coordinates to find the shop in the market or a square on a chessboard, maps also use a similar system of coordinates. The system helps us find the exact location of any place on the earth using the 2 numbers. Let's learn how the system works and how it helps us find places on a map easily. Latitudes, that is written to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed points at the top and the bottom are the 2 poles. Halfway between them is the equator. Note the circle marking it, figure 1.3. Let's go back to the globe. It's easy to find the North Pole at the very top and the South Pole at the very bottom of the globe. The North Pole is the northernmost point on Earth, located in the Arctic Ocean. The South Pole is the southernmost point on Earth, situated on the continent of Antarctica. So if you spin the globe, these 2 points stay in the same place. The top and bottom don't move. Halfway between the North Pole and the South Pole, there is an imaginary line called the equator. Look for the circle that goes around the middle of globe. That's the equator. You can see it in figure 1.3. Imagine that you stand on the equator and travel towards one of the poles. Your distance from the equator increases. Latitude measures this distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west parallel to the equator. Such a line is called a parallel of latitude and it draws a circle around the earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by the parallels of latitude grow smaller as we move northward or southward, figure 1.3. So now we are going to learn what is latitude. Imagine you are standing on the line of equator, the line around the middle of the earth. Now, if you start traveling toward either the North Pole or the South Pole, your distance from the equator gets bigger. Let's say you are traveling towards the North Pole, so your distance from the equator gets bigger. Latitude is the way we measure this distance from the equator. At any point during your travel, you can imagine a line that goes east to west, parallel to the equator. Parallel means they never meet or cross each other. They stay the same distance apart no matter how far they are. This line is called a parallel of latitude and it goes all the way around the earth making a circle. On a globe, you will see that the biggest circle is the equator right in the middle. As you move closer to the poles, the circles made by the parallels of latitude get smaller and smaller. Latitudes are expressed in degrees by convention. The equator is latitude 0 degree, while the latitude of the two poles are 90 degree north and 90 degree south respectively. This is noted 90 degree N and 90 degree S. So latitudes are measured in degrees. People around the world agreed on a standard way to measure and describe latitude. That is by using degrees. The equator is 0 degree latitude. That is 0 degrees. The North Pole is 90 degree north, written as 90 degree N. The South Pole is at 90 degree south, written as 90 degree S. So, when we say a place is at a certain latitude, we are saying how far it is north or south from the equator. For example, moving north from the equator, we have 15 degree north, 30 degree north, 45 degree north, 60 degree north, 75 degree north, and finally the North Pole at 90 degree north. Similarly, moving south from the equator, we have 15 degrees south, 30 degrees south, 45 degrees south, 60 degrees south, 75 degrees south, and then the South Pole at 90 degrees south. I hope this helps you understand how latitude is used to measure the distance between a place and the equator. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is also called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperate, and closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so and also why we experience different seasons in the course of a year. So what we learn here? Latitude is not just a number. It helps explain the kind of weather or climate a place has. Near the equator, that is 0 degree latitude, the climate is usually hot. This hot area is called the torrid zone. When you travel away from the equator towards the poles, north or south, the climate becomes moderate or comfortable. This is called the temperate zone. Near the North Pole or South Pole, that is 90 degree N or 90 degree S, the climate is very cold, which is called the frigid zone. Later, you will learn why this happens and why we have different seasons during the year. Longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well pass through Asia. The distance will be the same. These lines are called meridians of longitude. Figure 1.3. They are all half circles running from one pole to the other. Now, let's say you're traveling from the North Pole straight to the South Pole in the shortest way possible. When you look at the globe, you will see that you can pass through many different places. Like, you can pass through Europe like this, or like this through Africa, or like this through Asia. But the distance from the North Pole to the South Pole stays the same, no matter which path you take. This means that all directions from the North Pole to the South Pole are equal. These lines that run from the North Pole to the South Pole are called meridians of longitude. You can see them in figure 1.3. These are half circles that connect the two poles. You will also learn in science that the Earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe focused on it. And imagine that this is the sun illuminating the Earth. Slowly rotating the globe eastward, we can note that for some places on the Earth, it is morning, while for others it is midday, evening or night. When it's breakfast time in one country, it's lunch time in another. And in a third country, people are fast asleep. That is why by measuring the longitude of a place, we will also be measuring the time at that place. Let us see how. So we will be learning in science that the Earth spins around an imaginary line called its axis. To understand this better, let's try a simple activity. Place a desk lamp a little away from a globe and shine its light on the globe. The lamp acts like the sun and the globe represents the Earth. Now, if you slowly turn the globe eastward, the same direction, the Earth spins. You will notice for some places it's morning because the light is just beginning to fall there. The sun is rising in those places. For others, it's midday because they are facing the lamp directly. This is where the sun is highest in the sky. For some, it's evening or night because the light is moving away or not reaching them at all. These places are in shadow, just like night on Earth. So, when people in one country are eating breakfast, in another country, it might be lunchtime. And in another country, people are fast asleep. The Earth spins and as it turns, different paths face the sun. This is what causes morning, afternoon and night. That's why when we measure the longitude of a place, that is its position from east to west, we can also figure out what time it is there. We will find out how that works. To measure longitudes, we need to define a reference point called the prime meridian. Figure 1.3 on page 15. It is also called Greenwich meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, could become the international standard for the prime meridian. It is marked as 0° longitude. So, to measure longitudes, we need a starting point called the prime meridian. The prime meridian is an imaginary line that is marked as 0° longitude. It's also called the Greenwich meridian because in 1884, many countries agreed to use the line passing through Greenwich, a place in London, England, as the starting point for measuring longitude. This line helps us know how far east or west a place is from the prime meridian. And you can see this prime meridian on the globe in figure 1.3 on page 15. Just as latitude is a measure of the distance from the equator, if you travel towards one of the poles, longitude is a measure of the distance from the prime meridian if you travel along the equator. Longitude too is measured in degrees, westward or eastward. It increases in value from 0 degree to 180 degree with the letter W or E added. For instance, using round figures, New York's longitude is 74 degree west, while Delhi's is 77 degree east and Tokyo's is 140 degree east. So just like latitude measures how far you are from the equator when you travel north or south, longitude measures how far you are from the prime meridian when you travel east or west. Longitude is also measured in degrees. It starts at 0 degree at the prime meridian. Going eastward, longitude increases up to 180 degree east. E means east. Going westward, longitude increases up to 180 degree west. W means west. For example, New York is at about 74 degree west, 74 degrees west of the prime meridian. Delhi is at about 77 degree east, 77 degrees east of the prime meridian. And Tokyo is at about 140 degree east. Don't miss out. As you can see on the globe of meridians of longitudes, 180 degree west and 180 degree east are the same longitude. So this longitude is noted 180 degree, omitting the letter W or E. On the globe, you will notice that 180 degree west and 180 degree east are actually the same line. That's because 180 degree west and 180 degree east meet on the exact opposite side of the prime meridian. So instead of calling it 180 degree east or 180 degree west, we just say 180 degree. Latitude and longitude together are the two coordinates of a place. With them, you are now able to locate any place on earth. You can now understand a statement such as Delhi lies at 29 degree north latitude and 77 degree east longitude. These values are rounded off, not exact. So latitude and longitude are like two coordinates that help us find the exact location of any place on earth. Using these two numbers, you can say exactly where a city or country is. For example, Delhi lies at 29 degree north latitude and 77 degree east longitude. So what are the coordinates here? 29 degrees north and 77 degrees east. What does this mean? Delhi is about 29 degrees north of the equator and about 77 degrees east of the prime meridian. Remember, these numbers are rounded off to make it easier to understand. Now, you can also use latitude and longitude to find places anywhere in the world, isn't it? Figure 1.3 on page 15 shows the parallels of latitude and the meridians of the longitude together on the globe as blue lines. All these lines together constitute a grid for the globe. They are also called grid lines. In figure 1.3 on page 15, you can see the parallels of latitude and the meridians of longitude drawn on the globe as blue lines. All these lines together make a grid around the globe and these lines are called grid lines. So what are grid lines? Grid lines are imaginary lines drawn on a globe or map. They include parallels of latitude, lines that go east to west, and meridians of longitude, lines that go north to south. Together, these lines form a grid, just like the squares on a chessboard or graph paper. This grid helps us find the exact location of any place on earth by giving its two numbers, its latitude and longitude. So grid lines make it easy to locate places on maps and globes. Let's explore. If the globe or atlas in your class has well-marked latitudes and longitudes, try to note down approximate values for the latitude and longitude of Mumbai, Kolkata, Singapore and Paris. If your globe or atlas has clear lines for latitude and longitude, look for these cities on the globe. Then note down its latitude, how far it is north or south from the equator, and its longitude, how far east or west from the prime meridian. This will help you practice using grid lines to find places on earth. First, we have Mumbai. Mumbai is located on the west coast of India, somewhere here. So, its coordinates will be approximately 19 degree north and longitude 72 degree east. Next is Kolkata. Kolkata is located in eastern India, specifically in the state of West Bengal, approximately here. So, what will be its latitude? 22 degree north and longitude 88 degree east. Next one is Singapore. We need to find Malaysia first because Singapore is located at its southern tip just below Malaysia. So, let's find Malaysia. Malaysia will be somewhere here. And below Malaysia, a tiny dot, that's Singapore. Singapore is a small island, city and country at the same time. So, its location is latitude almost 1 degree north and longitude 104 degree east approximately. The last one is Paris. Europe will be here. Look for a country that's kind of shaped like a hexagon. That's France. Now in the northern part of France, you will find a city, Paris, the capital of France and famous for the Eiffel Tower and one of the fashion capitals of the world. Its location will be approximately 49 degree north latitude and 2 degree east longitude. Figure 1.4. This sketch shows how the prime meridian divides the earth into the western and eastern hemispheres, while the equator divides it into the northern and southern hemispheres. Here we have the prime meridian and here equator. The prime meridian divides the earth into the eastern hemisphere and the western hemisphere. The equator divides the earth into the northern hemisphere and the southern hemisphere. The prime meridian divides the earth vertically into two equal halves, while the equator divides the earth horizontally into two equal halves. Don't miss out. The Greenwich meridian is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own. Figure 1.5. It was called Madhyareka or middle line and passed through the city of Ujjaini, today Ujjain, which was a reputed center for astronomy over many centuries. Varahamihir, a famous astronomer, lived and worked there some 1500 years ago. Today, we use the Greenwich meridian as the prime meridian. But did you know Greenwich was not the first prime meridian in history? Long before Europe, ancient India had its own prime meridian. It was called Madhyareka, which means middle line in Sanskrit. This line passed through the city of Ujjaini, today known as Ujjain, in the state of Madhya Pradesh. Ujjain was a very important place for astronomy many centuries ago. A great Indian astronomer named Varahamihir lived and worked there around 1500 years ago. He and other scholars studied the sky, stars, using Ujjain as the center point. Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or prime meridian. The Ujjaini meridian became a reference for calculations in all Indian astronomical texts. So, a long time ago, Indian astronomers already knew about latitude and longitude. They also understood that we need a special starting line called a prime meridian to help with these measurements. In ancient India, the city of Ujjaini, which is now called Ujjain, was used as the starting point. This Ujjaini meridian became the main line for making calculations in all Indian astronomy books. The map shows a few ancient Indian cities close to the Ujjaini meridian. Some are very close to it, while others are a little away. That is because measuring longitude required accurate timekeeping, which was not as precise then as it is today. This map shows some old Indian cities near the Ujjaini meridian. Some cities are very close to this line, while others are a little farther away. This happened because long ago it was hard to measure longitude exactly. Accurate longitude needs very precise timekeeping, which was not easy in ancient times. The cities that are marked with circles on the map were mentioned in old astronomy books. You can also see their modern names written next to them. Here we see Kurukshetra, Rohitaka. Rohitaka is also known as Rohtak. Delhi, Malavangara or Nagar, Ujjaini, which is Ujjain today, Mahishmati, which is Maheshwar, Kolkata, Mumbai, Chennai, Bengaluru, Kumari or Kanyakumari, which are modern cities now. Figure 1.6. This map, published by the Survey of India, shows the country's outline along with a few parallels of latitude and meridians of longitude. India's latitudes extend approximately from 8 degree north to 37 degree north, and longitudes approximately from 68 degree east to 97 degree east. The two colors have been added. So in figure 1.6, which shows the outline of India, we can see some parallels of latitude, which are over here. These are parallels of latitude, and these are meridians of longitude. India's location on the globe is between about 8 degree north to 37 degree north latitude. This means India stretches from 8 degrees north of the equator to 37 degrees north, and about 68 degrees east to 97 degree east longitude, which means India stretches from 68 degrees east to 97 degrees east of the prime meridian. With this, we have completed part 2 of our chapter, Locating Places on the Earth. We hope you found it useful and easy to understand. If you enjoyed the video, don't forget to like, share and subscribe to our channel. Thanks for watching. We will see you again in our next video. Bye bye.